because the machine cannot handle it. It gets so confused with on a 3D. And by the way, what is called 3D and 2D, it's not, I think, is not appropriate way of calling this examination. What they mean by the manufacturer 2D and 3D, it means that with septa, without septa. Okay. That's what they call 2D and 3D. It means 2D is with septa, so there is only the vertical photons. 3D is with the oblique photons. But is not the picture that the current PET are showing are a rotating image that show the accumulated photons within a certain time, the integration of number of photons acquired within a certain time.
Yes, it doesn't imply that the image that the reconstructed image is just a term that's used.
Yeah, and it rotates them.
Dario, getting there, what type of reconstruction algorithm do you plan to?
Okay, good question. Good question, and let me see Siemens CDI. The first Siemens CDI, yeah. The first my goal is to improve the machine and to provide the same protocol, the same format that is called PET link. So shipping and using the standard reconstruction program. And then the second stage, because this R&D may be long in order to make all the improvement, okay? But my first goal is to build a machine that is measuring more accurately the photons and capturing more photons. That is the goal. And so providing the information in a 64-bit word, and is also on the book, is a chapter, the format of the word and the meaning of each bit. And typically there is the coordinate of the photons in one end of the detector, coordinate of the photon at the other end of the detector, and then there are some information like time, depth of interaction. If you have a depth of interaction, but most of current PET don't have, there is the HRRT for the hand that has that. Yes, what I envision here is to use the same format, the PET link, and being PET link compliant. So one issue at a time, no CT at first, no reconstruction, and I know that the binning cannot go too far on if you extend the field of view and if you take oblique photons. However, we have experiment like the two experiments that were at the Super Collider, $500 million. The PET is 16 centimeters long. This is 48 meters long, 23 meters in diameter. Particles, all sorts of particles. The reconstruction is curved, is in 3D, analytical, and without using binning. Okay. So there are solutions. I just don't expect to tackle all of them at once. I want to stay away from the CT problem, just renting or buying one, put in before getting a very low radiation to determine the attenuation coefficient, as it has done. All the CT PET are built like this now, and then there is the fusion of the image, as you said, the LS. So, and then the data collected, same format, PET link, go to the reconstruction program. Then next step is The format can be the same, 64-bit word, and coordinates, and same bit assignment, but treating differently. Or, as I said on the book, I envision to provide more information in that protocol in that word. Means the information of the time, depth of interaction, that now it is not there. Yes.
I have a question from the audience.
Yes.
How much is the heat dissipation of your electronics?
Okay. Can we? Okay, I can answer quickly now, and then because maybe this person, is there a name so you can tell the name of it?
Barone, B-A-R-O-N-E.
We will see the detail of this board. I still have to test and stress the board to the maximum performance, but I estimate that it will not be over 30 watts. Okay. And I will show you all the power, because that was a big consideration, a big concern and study on this. This is the reason why I am getting the power supply from the pin of the PCI to supply the power to a few components, and then most of the power supply is from this other connector that is an external connector. Okay. So I will show you the cooling. I have the accommodation of 16 of this board per chassis. The cooling can support that. The power supply can support that. Is a redundant power supply. It means that if one of the 4 power supply fails, I can extract it while the power is on, and the other take over and then replaces, and there is always one redundant that can that is for the power supply. But a good question, and we will see on the application. By the way, this is using the fully programmable FPGA that have a silicon die inside that is at least 4 times the die of another version that I intend to use on the final machine that is called hard copy, Altera. So there you shrink the size of the silicon, you lower the power, and you increase the speed. So you have several gains and lower the price a lot. Yes. Yes, and the price is lower a lot. Okay. So there are, but still, I could put 16 of these in. I've done the calculation to have 16 of these on a chassis, although I will not build 16 fully programmable because the cost will be exorbitant. Thank you for the question. There is more on this board if I could pass it around. And this is the complete design of the board. That okay, there is a first of all I introduce this design. Well, I designed it and I put it on a concept HDL from Cadence. That is one of the most advanced tools. There are about 28 pages of the concept, and then all the database of this schematic is passed to another tool that is called Allegro, and the Allegro, this was the key, and let's say the innovation part is placing the components in a certain way and assigning the signal to the pin in a certain way that I optimize the routing and eliminate as much as possible the crossing, the via. Okay. So it paid off because at the end the result is 8 layers instead of 20 layers of signals.